Hello, this project is for design and manufacturing class taught by Dr. Hassan Rashidi in spring 2022. Our team project title is Adaptability in Relation to Productivity, and our team members are Olivia, Jung, Rachel, Josh, and Raul. History of manufacturing. The Industrial Revolution changed human life and manufacturing process drastically. Prior to 18th century, all the products were handmade and there was no factory at all. More was created in the last 250 years than in the previous 2,500 years of known human history. There are 4 steps of Industrial Revolution. In the 18th century, first Industrial Revolution, mechanized production using water and steam. In the 19th century, second Industrial Revolution introduced many production with electric power. In the 20th century, third Industrial Revolution, digitizing production using the internet. Fourth Industrial Revolution, which is occurring today, refers to rapid technological advances with physical, biological, and digital connections. Current manufacturing in the United States. Manufacturers in the United States account for 11% of the total output in the state, which is more than $2,000 billion and employing 9% of the workforce. Therefore, the manufacturing industry should be developed more because it is an economically important sector. There are new initiatives regarding supply chain, technology, and clean energy.
Current manufacturing challenges. Currently, the supply chain issue is a big issue since recently the Suez Canal incident caused a shipping container to get stuck in the Suez Canal, which halted trade for a couple of days, and that showed the high reliance on outsourcing from other countries for manufacturers and their struggle to produce their goods on time, as well as another challenge being a labor shortage where manufacturers are unable to find skilled and unskilled workers to fill the jobs that they need. And adaptability is another challenge since the lack of it causes a halt in production and manufacturers. As for the main challenge, we chose adaptability as it relates to productivity in the manufacturers. The lack of adaptability can lead to product variety being low, greater impact from labor shortages and the inconsistent outputs of their goods, and the heavy reliance on assembly lines causing them to not be able to adapt to the changes in the halting of a portion of it. As for possible solutions, we chose one of them to be improvement in smart manufacturing systems and spatial organization. Smart manufacturing systems are the fourth industrial revolution's advancements in such things as automation and big data, and better spatial organization being a overall better layout of the workplace. Another solution was the education incentives for current workforce, which just adds incentives to workers to be able to learn new skills so they can be better moved within the workplace. Another possible solution was the intuitive software interface increase, which would allow manufacturers and workers to better use data within the company. And overall, we chose smart manufacturing systems and spatial organization.
Smart manufacturing systems are highly dependent on automation technologies. These are the 3 types of automation currently used in the industry. First of all, we have fixed or industrial automation, which refers to a rigid sequence of operations that have been automated. This is suitable for single part production in large volumes. However, there can be safety concerns for humans who work with the equipment. Next, we have programmable automation, which is suitable for the batch production of parts. Compared to fixed automation, programmable automation is capable of producing better quality parts, but in lower quantities. The production equipment also need to be reprogrammed for each part, which leads to a large amount of equipment downtime. Lastly, we have flexible automation, which is capable of on-demand production. Programming for flexible automation is done on a computer terminal, making it more intuitive for users and also saves the time spent on reprogramming the equipment itself. That being said, here's our solution to the main challenge of low adaptability and productivity. We propose upgrading conventional production lines by combining 2 new technologies, a magnetic assembly line and cobots, also known as collaborative robots. The first image is taken from ABB Robotics to illustrate the concept of a magnetic assembly line. Parts are transported on shuttles made of magnetically levitated planar motors on an open adaptive workspace. The shuttles have 6 degrees of freedom, which allows them to freely move around on the workspace. Each part can navigate its own way through the production process, thus removing the need for a rigid sequence of steps. On the other hand, cobots are designed to work alongside humans. They are easy to reprogram, for example, with intuitive graphical user interfaces or by demonstration. Human-robot collaboration combines the ability of humans to deal with variability and the high efficiency of automation.
This brings us to the first prong of our solution, which is the magnetic assembly line. Like Rachel mentioned, this allows us to bring things away from a traditional assembly line. This means if a product only needs to go through station 1 or station 2, it can do so, or if it needs to go through both stations, it can also do that. This solves some of our adaptability issues caused by supply chain shortages and a changing consumer who also wants customizable products. What I mean by this is some products as they pass through nowadays, the variety needed is not allowed on a traditional manufacturing line. Our solution of a magnetic assembly line that allows you to pick and choose stations for products to pass through as needed allows for product pivoting, meaning that when a part is not available to make a certain product, you can move to a different product. And it also allows for agile manufacturing, meaning when you're thinking about how to produce a part, you already have a variety of stations that are interchangeable and not a set sequence that you have to stick to. It also allows for a labor reduction because not all stations would have to be manned at all times. This brings us to the scalability factor of our magnetic assembly line. What's important to note about an assembly line that doesn't require every station to be manned is that businesses from small to large can use it. These stations can be added or removed as needed, especially on the traditional line assembly. This ability to quickly adapt raises your overall productivity numbers because you can quickly shift from creating one product to the next. This brings us to the second prong of our solution, which is collaborative robots. Collaborative robots are important to note in today's manufacturing world because they have improved safety. What I mean by this is when you incorporate people into their production stations, their safety features allow them to stop when they touch a foreign object, whereas traditional manufacturing robots frequently cause severe harm to workers. In doing so, you can double your output or teach a cobot to complete a person's task without ever taking downtime away from your system. Additionally, as you continue to phase collaborative robots in, meaning you can add as many or as little as you'd like, depending on the needs of your business and your scale of production, you can get a consistent production rate with just cobots. This allows you to negate some of your supply chain issues because you know how much you'll be producing each week and therefore how much you need in parts.
Taking a look at our total integrated solution, you can see on the diagram to the left there, we have cobots on the right side unloading and loading products, and on the rest of the diagram shows the proposed magnetic assembly line. So as they move through, you can see that there's 3 station Bs labeled B1, B2, B3. So that causes the products to be able to go through parallel processing and redundancy, meaning that products can move through all 3 of those stations at the same time that are doing the same thing, so more product can move through. And also, if one of those stations is to go down, the products can be rerouted to the remaining 2, so there is no downtime at all. You can still making product. Those stations can also be changed out with cobots or humans or a combination of both, or removed entirely, which kind of plays to the adaptability that we've been talking about this whole time. And as well as the, like I mentioned earlier, the humans and cobots can be working together, and those stations can also change depending on what product the company wants to be producing, and they can be swapped out easily, and production doesn't have to stop in order for that to happen. So obviously we're moving towards the end of the 3rd industrial revolution here, kind of moving into the 4th. Our final solution kind of works with the 3rd, and it would only become better with the 4th industrial revolution. With new AI and technology coming in, it'll just make that process better and remove humans from it entirely, which would make it a lot more adaptable and productive. The 4th industrial revolution would really help with sustainability, supply chain resiliency, and labor shortages. All those would hopefully become problems of the past as AI begins to take a larger role in our world and in manufacturing. Here's just some of our sources we used throughout this presentation. So that's the end. Thank you for listening, and we will any questions at this time.